capabilities that have been added in C++17. And for this, I will help you to understand, okay, with the help of various examples. And as part of this, I will also, okay, demonstrate it on couple of compilers. So there is a degree of compiler support that exists, that is there. So I'll be using different compilers so that you can understand it. At any point of time, if anyone has any questions, you can ask me, and I'll be happy to answer them. I suppose all of you can hear me clearly and you can see my screen. Very well. So now let's get started, and let us take up, okay, the first capability that has been added. So before I take up that, I have a simple question for all of you, and the question is, what is the latest version of C++? Can anyone answer this question? Anyone would like to attempt to answer this? What is the latest version of C++? Very well then. So I will answer it. See, if the question is formed like this, that what is the latest version of C++, in a way the question is incorrect. In fact, the correct question would be, what is the latest standard for C++? So the latest standard for C++ is C++20, and C++23 is under development. So there are many capabilities that have been added to C++20, and C++20 was standardized couple of months back. So still the support for C++20 across various compilers is not that clean, and compilers are trying to add the capabilities, and they are going to do it, okay, as when their objectives are met. But okay, C++17 was standardized 2 years back. C++17 was standardized in 2018, and now the support for C++17 is consistent across various compilers. And over here, I would like to mention 3 compilers. The first one is GCC. The second is CLang. Is okay, Microsoft Visual C++ compiler, or your cl.exe. The tooling for support for C++17 across different compilers is quite standardized, and the 3 major compilers, they have support for it. There are other compilers also that are there, okay, such as the IBM compiler. Then you have the Ember Kedro compiler. Then you also have IBM. Okay, IBM I already said, the Symantec compiler, and so on. So they are also there. So these compilers are also trying to come up to the requirement of C++17. So a major motivation in C++17 is to make the code more cleaner and readable. So many capabilities that are there that have been added. So it is to make the code more cleaner and readable. And if we have to understand the capabilities that have been added, the capabilities can be divided into two parts. One is the core language, second is the libraries. So capabilities are added at two levels, that is at the core language level and at the libraries level. So in this webinar, my focus is on the core language. So what are the capabilities that have been added in the core language? So now let me take up the first capability that has been added in the C++17. So I'm going to discuss a capability which is called as auto template argument deduction. So this can make the code quite readable, and specifically when we have long templatized types. So it can also help save in keystroke typing. What is this capability? So to understand this, let me write some code. So over here, I'm using code blocks. So you can see this is code blocks IDE, and code blocks I'm using 20.03, and internally it is using GCC 8.1. So if you would like to develop C++17 applications for GCC on Windows, then in that case, one of the options that you have is code blocks. So 8.1 nearly has all the support for C++17. There are a few things here and there that are not supported, where you would require the GCC 10. Thereafter, if you want to toggle between the compiler settings, then you can come to settings and go to the compiler, and then over here you choose global compiler settings from the left hand side, and on the right hand side choose the tab compiler flags, and then you can see over here there are different compiler options that are available for which standard you would like to compile. So as you can see, there is C++ 98, 11, 14 and 17. So what I will do is that I will choose over here C++, 17. Say OK to it. So let me include my headers. So what is that I'm explaining now? I'm explaining the concept of auto template argument deduction. So that's the program. IO stream. And over here, I'll write a function called, say, fx. We return 0. And then over here, I have my function. I'll write one more function. say I have and over here I'll create a tuple. So tuple is one of the aggregates that's available, and over here I'm going to templatize the tuple with various types. So I have bool, character, tuple, and then we initialize it. T 34.56 say true, A, and some other number. Now this is supported in C++ 14 as well. So to work on tuple, let me also include over here. Okay, we exactly do not require string for tuple. I have included string so that later when I work with string, I will use that. And now over here, I'll create one more tuple. I say object2 is initialized by object. And then over here, I create tuple of object3. Then, okay, I initialize this with some values. 0.5 character, some boolean, and some and thereafter over here let me display the details regarding the type. I can say type info, type ID, dot name, and here object2 and object3. So as you can see at line number 9, I am initializing object to object2 of tuple. So over here, whatever is the content of object2, it will be copied to, say, object to object2 will be copied. And then over here, as you can see that I have object3, and object3 is initialized, okay, with various values. The point that I want to stress upon here is there is auto argument deduction. There is auto argument deduction. As you can see that over here, object2 and object3, they have not been templatized or parameterized. So the compiler, it infers what is the templatized types based upon, okay, what is the L value. So over here, if I compile it and execute it, we can see the result. Compiler error, let me see. So it gives me one error. Okay, let me see. Okay, it still gives me error. Okay, this looks to be fine. Okay, let me take another compiler over here. So I can take wandbox.org. In meantime, let me also start Visual Studio. So I think the program is correct. Okay, is there any typing error or something?
After IOStream, I think there is an extra Angular brace.
Oh yes, that's correct. Still, it is not able to infer.
There is lack of include tuple.
Okay, let me comment it out. Okay, let's just try this part.
Can we try including bit/std++ library? Instead of this?
Okay, let me include map. Let me see if it takes. Okay, it is taking map. Okay, so the mistake that I had in this was here I had not included map. So, tuple exists over there. So now it's compiling fine. So all of you can see over here that it is able to deduce and identify the templatized type. Now the litmus test for this is we go to settings, we go to compiler and come up over here and choose C++, say 14, and then compile it. So as you can see over here that in C++ 14 compiler settings, this fails. This fails because it is not able to identify over here the types. So C++ 14 standards do not support for auto template argument deduction. So just to recap what I have said, at line number 10, I have created a tuple with various parameters, and then I have initialized that to another tuple object. So C++ 17 has this capability where it can infer that the type or the template types based upon the L value. And then over here at line number 12, as you can see, I'm creating one more tuple. I have not identified the parameters or the templatized arguments. So you can see over here that it is able to infer. Okay, so let me enhance this program a bit more and let me create a user defined type. So over here I have set type name. Okay, T2. Then I have type name of T3. I create a class employee. And in this, I will have some employee state. So I have employee number. Then I have employee name. Then I have the salary. Thereafter, I'm going to create a constructor, and here the constructor will take 3 arguments. And then thereafter, initialize our state of employee. So we have the EMP name, I have the name, and then I have the salary. And I'll just put one helper method, or say helper information. So employee constructor. And once I have done this, I'll come to my function fx2, and here I'm going to create employee objects. I have employee, int, I have string, I have int, object, and I can say 10, ram, and then I can come up to next line and create one more object. Say object 2 is initialized by object, and then I have object 3, it is 11, name is Sham, and 109. And then I display the type information. Just to verify what we are doing. So I have type ID, I have object, name, and this, okay, 2 times, and 3. I think that should do it. I hope there are no typing mistakes. Okay, let's compile this. Okay, so I have to change my compiler. So I can come up here and choose it. So all of you can see this, that okay, my object is getting created. And here is my auto template argument deduction. That's occurring. This is auto template argument deduction. I hope you guys are able to understand this. Let me show the same example in Visual Studio as well. So let me paste my code here. So in Visual Studio, what has to be done is you have to go to the properties to identify the compiler. So go to properties and come over here to C++ and come to language. Under language, okay, you have this option which is a drop down which says C++ language standard. So here you can say it is C++ 17. You can choose that and say OK to it, and then you can compile and execute it. So over here, a Visual Studio compiler, it is more elaborative in terms of giving type information. So as you can see over here that the type information is far more readable. So the readability of type information is far higher compared to when using the GCC. So this can provide greater indication and verification of what you are doing. Similarly, I can go to Wandbox. So Wandbox is a excellent online IDE provider. So this has support for various compilers. So if you come to the left hand side, you see this option. It says GCC head. So you can identify which compiler you would like to use, and it has support for many languages that is there. So under C++ also it has support for various compilers. So I can come up here and I can choose GCC 8.1 or GCC 10.1. So I choose that and I can now execute it. Okay, it is still the old one. So let me copy the new code. Right. So now let me run it. So now we can see over here, it is there. Okay. Very well. I hope you guys are able to understand this capability. So this is called as the auto template argument deduction. It is quite helpful. It enhances the readability of the code. I don't have to parameterize my type. It will automatically identify and infer it based upon the assignment. So let me just put the code over here in the notepad. Very well. Anyone has any questions at this point of time? Okay, then I guess I shall proceed further, and now I'm going to help you understand the next capability that is there in C++ 17, that is called as structured binding. Okay, it is called as structured binding. Alternative name for this is aggregate decomposition. So aggregate, as you can understand, is a type that can have various data in it. So how we can perform aggregate decomposition, or how we can have structured binding. One thing that you should not confuse is that it is only limited to structures. So it is just a term, that structured binding, and in reality what it is that it is aggregate decomposition. Now to understand this concept, let me help you. Okay, let me write a program for this. Here, first we'll include IOString, then I include over here string, namespace std. I have a struct employee, and I have salary, and then over here I have employee name, and we create a constructor. You have employee number initialized by E. Okay, employee name, and and then I have salary initialized by S. Here I have chosen structure. I could have also chosen class. So later, while enhancing this program, I am going to also make this as a class. Thereafter, I have a function fx. I have another function, say fx2, and then I have main. You have fx2. So let's write fx inside it. So I'll create an employee object. We say 10, 108, and here I say auto. As many of you might know that auto keyword is existing in C++ from C++11, and it helps us to infer the type based upon what is the assignment value. So over here I say auto of EMP number, sal, and EMP name, and it is initialized by obj. Thereafter, over here I can say extraction. I have employee number, and I have employee name, and then over here I have salary, and make things more clear, let me also display the type information. So type, so I'll say type ID, EMP number, of name, ID, EMP name, then finally we all have type ID sal dot name. So I think this does it. I hope there are no typing mistakes. Let me compile this and execute it. So we can see over here that our program is working fine. So after extraction, it gives me the values as 10, RAM, and 108. So that's what the values that I initialized. And then I have over here my type information that is there. So the first and the last arguments are inferred as integers, and the second argument is a string. So GCC infers string with type ID this way. Over here is my aggregate decomposition. This is where the aggregate decomposition is occurring. Now to verify that this is C++ 17 capability, I can come up over here and change the compiler to 14. And now I can compile it again and execute it. It works. But over here, if I Okay, come up and compile it. I draw your attention in my build messages. So in my build messages, GCC identifies the usage of structured binding as a warning if the compiler is not set to 17. So you can see over here, it gives me a warning. It says that structured binding only available with C++ 17. So I am using it with C++ 14, but it identifies this as a warning. Now we can take the same and we can come to over here, vent box. Paste it, and then I can run the code. So you can see over here that it works fine. It doesn't give me any kind of warnings because I'm using GCC 10. So GCC 10 is compliant with the you say C++ 17. So it is working fine. Similarly, later you can try out with other compilers as well. So let me enhance this program a bit more, and let me come up over here to my fx2. So let me write some code in fx2 as well. So here after I create an integer array, I initialize it. With some values, and then I say auto, and I can say I comma j. It is initialized with here, and I can say cout after extraction. You can say I j, and then we have cout, and I'll say type. And in this type ID, so I have j, and I think I should do it over here. One thing that I have to do now is I have to change the compiler settings. So I choose the compiler, and here I'll choose 17. I say OK. So I did not finish it. Okay. So we can see over here that it gives me type information as I comma I, and after extraction it gives me okay 1 comma 2. So here we are using the C++ 17 capability, which is called as aggregate decomposition, or alternatively called as structured binding. So if I come up and make one more change to our program, we'll make the structure as a class, and then we try. So over here we will get compiler errors because okay, everything has become private. So over here my elements have to be public, then only the aggregate decomposition will work. So you can see now it even works for class. I hope all of you are able to understand this. Yeah. Anyone has any questions at this point of time? Very well then I guess I shall proceed further, and let me show you one more example on aggregate decomposition, and that is with the help of a for loop. So let me remove this code. So I have a function fx. I say map int of string. So this is pretty interesting how we can use aggregate decomposition, and that too when we use, you say, aggregate such as map, where we know that map is a key value association. So here I say object, and we initialize it. I say 10 is Ram, 11 is Sham, and 12 is Hari. And thereafter I can use my for loop. I can say auto and EMP number and name. We have employee number, out, and I can get EMP number, and then I can also get the name. So as you can see over here, I can use aggregate decomposition over here. So once I have done this, now what to do? We will compile it. Okay, so I have not included the map header, so let me include the map header. So I have one more error. Let me see if I have made any mistake. Okay, EMP number, name, okay, let me see the compiler settings. Is it C++ 17? Yeah, it is 17. Okay, there's a mistake. J, here we are. So we can see it has extracted the code. So it is 10 Ram, 11 Sham, 12 Hari. So over here I had put employee number. So that was the mistake. It should have been obj. So if I take this code and I put it in Visual Studio, and here we compile and execute. Okay, it works as well. So this is how, okay, you can use, you say, aggregate decomposition or structured binding with a for in loop. Similarly, okay, let me enhance this program a bit. Similarly, I can also use this, okay, with what is called as a tie. So here, what I can do is I can come up here and I can write one more function, say fx2 int I is 10 int j is 20. Then over here I have a constant auto and a comma b, and then I can say tie. Tie is a API that is available from C++11, and it can help us to combine various primitives as a tuple. So over here, if you see the signature, it returns a tuple. So I can come up here and identify I comma j. And then over here, what I'm going to do, I'll change a value to 20. And I'll say auto x comma y. And then I'll say tie of I comma j. And then over here, I'll change y value to 100. And then we will display the value for y. And then over here, I will display the value for b. So I'm showing you a couple of things within this particular function that I'm trying to show you. As you can see at line number 13, I have ij initialized to 10 and 20. After tie takes I and j, a and b are initialized. So this is our aggregate decomposition. This is the aggregate decomposition that is there. Thereafter, I have captured the reference. So as you can see, I have given ampersand, so I have captured the reference. So I update the value of a. And then again, I use type, and here we have aggregate decomposition. So the value of I and j are initialized to x and y. And then over here, y I update to 100. So I display the value of y. And then over here, I display the value of b. So b is over here, which will be the value of j. So now let me compile and execute it. So you can see over here the value that are given, y is 100, b is also 100. I hope you guys are able to understand this. Yeah, anyone has any questions? Very well, so let me just put this in the notepad, this code. So now let's take up our next concept of discussion. So the next concept of discussion that is there is initializer if. So this is a new capability that has been added in C++17. So this is a very useful enhancement that has been done. As you can see, whatever I'm showing you are grammar level enhancements that have been done in C++. I'm not showing you API level enhancements. So API level enhancements have their own importance, but far more important is the primary capabilities that have been added to the language. So one such capability that has been added to the language is initializer if. So what is initializer if? Initializer if is a mechanism via which my if statements can have okay, two, you say expressions, and they are segregated with a semicolon. As the name suggests, the first part is nothing but, okay, the initializer part, and second part is the condition part. Now, how this can be used? Okay, let me help you understand this with the help of an example. So I have namespace std void fx, and I can come up, okay, I'll write the code a little later. First, let me identify the method. So in this example, I have three functions. Then I have my name. So time being, I'll comment out fx2 and fx3. So how the syntax for initializer if is, you can say int I is equal to 35, and I, okay, %2, you identify the reminder. I can say cout is even I, else the number is odd. So this is my initializer if. So as you can see that my if statement, it has two parts. First is the initialization, second is the condition. So if I compile this and execute it, we see that it is working. Let me see what is the compiler setting that currently is in enforce. So it is C++17. So let me just compile it. Let me see the build messages. So we have the build messages. There are no warnings. There are no errors. Come back to the compiler and make the standard as 14. And then thereafter, okay, compile and execute it. So you can see over here, there's a warning that comes. So GCC shows this as a warning. Some other compiler might show this as an error also. So it depends upon how the compiler has implemented that particular feature. So it clearly says warning, okay, init statement in selection statements only available for C++17. So over here I have to choose 17. So this is the basic syntax of initializer if. If I want, I can enhance this a bit. So let me copy this and let me put this in fx2, and here I can say else if I %3 and is 0. So I can say over here it is say divisible by 2. Now this is just to demonstrate, okay, the initializer if. So you can see that I have also use else if, and in else if we have this instruction. And if I try to access I outside my if, I cannot access it. So the scope of I is limited only to the if. So if I compile it, you see that it says I was not declared in this scope. So we have it. So just to make things interesting, let me make I as 27, uncomment it. So you can see this. So you can see, you can differentiate between the messages. The first one is from fx, the second one is from fx2. Okay, so let me also show this over here. Let me show you one more minor variation that some of you might be interested in. I can say I is equal to 17, and then here I can say if int I is equal to 45, percentage 3. Out. Number divisible by okay, let me put then block, a code block, and over here let me try to access. So this is just to highlight one very important thing, and it is not specific to C++ 17 only. At line number 22, I have initialized I to 17. Now if I want to access the method level I cannot do so. So if I access I, this is going to access the if level I. So let me compile and execute it. So you can see that it displays I. And here if I say int I 90, so that's a global I. So if I want to access global I can use the scope resolution operator. Okay, you should not infer that it is negative. Okay, let me put arrow. So it is 90. Let me put one more function, say fx4. And in this, let me show you one more variation of initializer if. I can say int I is equal to 20, j is equal, k is equal to. Okay. I can do that, but let me make okay k as 50. I think that will be good. Yeah. And over here, I can say I plus j equals k. See how the numbers are equal. So now let me call fx4. So it says numbers are equal. So this is my initializer. So initializer if, just to recap, is a statement that has two expressions. The first is initialization, second is condition. And you got to keep in mind that when you use the initializer, it has to be of a specific type. So over here, okay, you cannot give a semicolon and make a j as double or k as float and things like that. So that is not feasible as of now. Very well. So let me take this code and execute this in Visual Studio as well and show you. So over here also it works. I hope you guys are able to understand this. Yeah, anyone has any questions? Very well. So let me proceed further and let me talk about one specific capability that has been removed from C++ 17. So in C++ 17, the API auto PTR has been removed. I guess some of you might be aware of what is auto PTR. Can anyone tell me what is auto PTR? I guess some of you might know it. Very well. Auto PTR is a capability that was added in C++ 98. And this was added to implement the concept of RAII, and auto PTR are also called as smart pointers. In C++ 11 was deprecated. Auto PTR was deprecated, and in C++ 17 it has been removed. And why is that it has been removed? It is because of inconsistent behavior. It is because of inconsistent behavior that auto PTR has been removed. And what I mean by inconsistent behavior, let me demonstrate it with the help of an example. So there are certain behaviors of auto PTR that are not desirable, and because of which our application can become unstable. For this, let me create one structure, and we have employee number, employee name, we have salary, and then over here I will write some functions. So the first function that I'll write is, say, employee operations. My employee operations, over here I create an object of employee using auto PTR. So auto PTR is there. I will use employee and we'll say new employee. And I will also include over here memory header. And thereafter, I'm going to go and call a function called as update employee object. This is my update employee. Update employee. And it updates also a auto PTR. What is that I'm trying to demonstrate? I'm trying to show you the weakness of auto PTR. I'm trying to show you how auto PTR can be ineffectively be used, or in other words, if programmers are not careful, it can be abused. So I'm trying to create a scenario which will help you to understand that. And I'm giving you a reason why auto PTR was deprecated in first place and now it has been removed. Object of the employee number, initialize it to 20. And I can say over here object is released. And then I come up and say object of employee number. And I'll set my compiler to 98. And now I'll compile it and execute it. So let me see. You can see over here there are no errors, no warnings. And then compile and execute it. So over here, what does it say? It says process returned with an error. So the program is crashing. You can see this. The process returned with this particular error. And why? It is because over here at line number 13, the object is already released. It is because this follows what is called as the RAI model, which is nothing but implementing mechanisms where objects are automatically calling their destructor, and in the destructor I set the required state for my object before it is removed from the memory. So what is really happening at line number 16? I am creating an object on heap. So object obj is referring that, and it is using the wrapper auto PTR. So auto PTR is a wrapper, and then I pass obj to update employee. It accepts it as auto PTR, and at this point the object is released. So once it is already released, I cannot access here. So these were some of the common issues which made auto PTR say unreliable to use. So because of this, in C++ 17 it has been removed. So if I come up over here to compiler and choose C++ 11, I say OK to it. So you can see now there is a message at line number 11. It says auto PTR is deprecated. Auto PTR is deprecated, and this is for C++ 11. Thereafter, if I come to the compiler and choose 17 and then I build it. Okay. So here also it still says it is deprecated. Okay. But this is okay, a behavior of the GCC compiler. In case of C++17, it has been removed. Okay, so it is better not to use it. So if you try in some other compiler, you will see that it might give you an error saying that it has no support now. But GCC, it is still having it because they have implemented it that way. So here we are. So as many of you might be aware that from C++11, we have a new API that is available, which helps us to implement the RAI model or smart pointers or the working with objects, that is shared PTR, weak PTR and unique PTR. So we are supposed to use them instead of auto PTR. I hope you guys are able to understand this. Very well. Anyone has any questions? Okay, then I guess I will proceed further. And now let me help you understand, okay, a capability of C++ that is quite popular from C++11 onwards, and that is called as the static assert. And this is compile time assertion. This is the compile time assertion. So we can assert at compile time. So that's what static assert is. And it is a very powerful capability that is there. So this was added in C++11. There is an enhancement that has been done in C++17, and that is from C++17 you can have static assert without message. For 11 and 14, if you use static assert, you have to give a message. But from C++17, static assert, okay, can be without a message also. So this is fairly simple and straightforward. How it works is like this. Over here, I can come up and say void fx. I can say static assert and 1, 2. Now again, I would like to highlight this, that the compilers that are there, they are from different vendors. So different vendors, depending upon the requirement, okay, they implement the capabilities in their compilers. In fact, some of the capabilities of C++14 were implemented by GCC in their compiler that supported C++11. So if you see that there is a variableness in terms of implementation, then you have to go and look at the support chart for the given compiler. So the capability that you're looking, when that capability was incorporated for the given compiler. So it may so happen that C++17 capability might be incorporated by a compiler when they release support for C++14. So that's also very much possible. So over here I have static assert, and here I can say 1 is greater than 2. Okay. This is not correct. So we have it. And I call fx. So I compile it, and so you can see over here that this is what we basically wanted. There is no execution of this program. The execution is the compile time execution. So you can see this, that my compiler, it identifies a assertion failure. So for line number 6, there's a failure. So this is not correct. And if I want, I can also remove this. And then I can compile. You see? So this is also identified as a valid instruction. So this is supported from C++ 17. So I can have a static assert without a message. It's a simple concept. So we have this, and now I guess I can show you the next capability. So one capability that has been added in C++ 17 is predictable method, call order. So there is predictable method call order we can have. And what I mean by this is, let me help you understand this with the help of an example. To this existing code. Okay, so let me write a class. So I have some class called test, and we have public test. What is there? My method. And it returns a test reference. So I can say my method is called. And as a return of this, you have test. The my method. I take k as an argument. My method 2 is called k. And then I write some other functions. So we have calculating for I have fx2. Cout. Calculating my method. I say return 20. Return 10. I think this should be fine. And then over here, I'll create an object, bj, and bj dot, okay, of fx. What is that I'm trying to demonstrate? I'm trying to demonstrate predictable method order call. That is, how the methods are called, we can predict the order of call. Prior to C++ 17, okay, the order call was unpredictable, which I will demonstrate in next couple of minutes. And fx2. So we have this, and okay, let me just verify whether I have written correctly. It looks to be correct. I hope there are no mistakes. Okay, so now let me compile this and execute it. Okay, I missed a semicolon. So you can see over here, let me just put this window a bit down. I think this should do. So you can see over here that it says calculating for my method. So it goes and call my method on object. Okay. So when it goes and calls my method, over here I call fx. So fx is called and it returns 10. Then my method is called. Then it goes and calls my, you say fx2, calculating for my method 2, and then my method 2 is called. Now this looks ordinary, but if I take this code and put it in one compiler, so we have one more cloud compiler available at C++ shell. So you can go to cpp.sh, and here, okay, I paste my code. I choose the options as C++14, and then I say run the code. Now you can see the difference between the output that I had got, okay, from my C++17 versus my another compiler. So you can see it over here. So it says calculating for my method 2, and then it says calculating for my method. Then my method is 10, my method is 20. So that's how the calls are occurring. So this is unpredictable. It is difficult to know if I have a method chain, how the methods will be called. So this is a predictable call. So this is one of the major enhancements that have been made in C++17. I hope you guys are able to understand this. Yeah, anyone has any questions? Very well then. So now let me proceed further and let me talk about what is called as C++ attributes. So C++ attributes were added in C++11, and in C++17 some new attributes have been added. So one of the attributes that has been added is called as may be unused. There is an attribute called as may be unused. It will the warning. So if you put it against a given variable, it will suppress the warning. So this is fairly simple and straightforward. So how this is done is like this. So consider over here I have void fx, and we have, so I say int j is initialized by add of 6, 7, and here I have int add I int j. Return I plus j. So now let me compile this and show you the warning. I have compiled it. So we can see over here, it says at line number 9 in the build messages, unused variable j. So what I can do is I can come up here and I can use the attribute may be unused. Okay, may be unused, and we can compile this now. So I missed one parenthesis. Okay, I add it. So now we compile, so that warning goes away. So that warning is no longer there. Let me show you again. Do not have it. Compile it. Okay, we have the warning. And another thing is, okay, we have to ensure we are choosing 17. Now let me put it. Maybe. So we see there are no warnings. A simple capability that is there, but in many scenarios where we don't want to have any warnings from the compiler, we want to ensure that the compilation is without any warnings and errors. At that time, maybe this capability can be used. Okay, so in addition to this, there is also one more attribute called no discard. There's an attribute called as no discard. What is no discard? Okay, no discard is identified with a return value type. So return value must be utilized by the caller. You see, return value must be utilized by the caller. And how this can be used? Okay, let me write a program and demonstrate it to you. So here I come and I will, okay, I'll need the add method. So we don't need this one. So here I'll come and say to the add, I'll say no discard. So the attributes are put in double rectangle parenthesis. Attributes are put in double rectangle parenthesis. That you have to keep in mind. Consider I have one more method, product. So I have this. I use my method. I say add 1, 2, and I say product. Okay. And now let's compile this. So over here, okay, we have some messages that are there. So you can see over here at line number 15, it says ignoring return value of add declared with attribute no discard. You see this? So only one warning, but does not give me that warning for product. It does not give me that warning for product. So over here, if a method has been marked as no discard, then a warning will come telling you that this is a no discard method and you are not capturing the value. Whereas a regular method that does not have no discard, okay, for that the compiler will not generate a warning. So if I come up here to my product and I make it as no discard and file it, and then I scroll down a bit, now you can see warning even for product. So it tells me that I have to capture the values. Okay guys, I suppose you are able to understand this. So these are some of the attributes that are available in C++ 17. There are some more attributes that are there like carries, dependency and all. So they also can be used. Very well. With this, I have come to the end of our webinar. So before I close the session, anyone has any questions to ask me? Anyone has any doubts? Very well then. So with this, I come to the close of this session. And if anyone has any further queries, okay, you can reach me out. As you might know, my name is Mahavir. Email ID is okay. That is GURUMAHAVEER@gmail.com. So that's my email ID. So whatever notes that I have created, okay, I will also share these notes for you for your reference. So it will be handy for all of you. Very well then. Thank you very much.
Yeah, hi all. Thank you all for attending this session, and also request you to please fill up this feedback form. The link has been shared in chat box. You have to just click it and fill it. Thank you.
Thank you, Mahavir.
Yeah, you're welcome.
Thank you, Mahavir.
You're
Thank
welcome.
you.